Hello everyone. Today we're going to go ahead and learn about sum and difference formulas of trig identities. Okay, so before we begin, I want you guys to go ahead and give it a try on this quick little do now, quick little warm up to refresh our minds about evaluating trig functions. So go ahead and pause the video and give this a try. We have cosine of 45. So if you've been studying your trig flashcards, you should know these by memory. If not, it won't be as bad. We can go ahead and see that this is 45 degrees. And we can see that, hey, this is our 1, this is our square root of 2. So therefore, this is 1 over square root of 2, right? Because our adjacent side, gives us square root of 2 over 2. Sine of 30, we can do the same procedure if you haven't had these already memorized. And 30 degrees, 30 degrees gives you 1 over 2. So it's going to be 1/2. Opposite over hypotenuse. Cosine, we can see that this is going to be 60 degrees. And if you don't know by memory, we can do it real quick. 60 degrees. This is square root of 3. This is 1. Sorry, what am I doing? This is 1 and this is 2. So my cosine would be 1/2. So quick little refresh of what we already know. Okay. So this one I went ahead and did it on Pear Deck as well. So this will not be in the notebook. This will actually be on Pear Deck. And it will be due at the end of class or the end of this video. Okay. So this is the last lesson before we go on our Thanksgiving break. So we're going to go ahead and learn how to use the sum and difference formulas. Okay. So overall, they're not that bad. But the idea here is that, let's say I was to tell you, hey, can you find me, I don't know, sine of 91 degrees or something like that. An angle that, and I picked this one because it gets my, I know it triggers some of you guys that it's not a perfect right triangle, a perfect right angle. But the idea here is that if I was to give you an angle, let's say 75, and we're right here, and we're like, oh snap, I have no idea what that would be. But what we're going to do today is like, we're going to be able to find an angle that we do know, like 30, 45, 60, 90, even a 225, or whatever the case may be, angles that we do know that we can evaluate sine, cosine, or tangent, and be able to add them or subtract them to give us what they are asking us for. So I'm gonna let that sink in. 75 degrees. Do you know an angle, well actually two angles that go ahead and add or subtract to give us the 75? Okay. So in order to do this, well, I mean, once you find them, in order to do this, you need to know that, hey, let's say it's an alpha plus beta. You're going to go ahead and say, oh, I'm working with cosine, and I know that two angles that go ahead and add or subtract to what they are asking for, right? So that's what the formula we're going to go ahead and use. Okay, so let's go ahead and jump into some examples. This, for the purpose of it being the introduction, I only did degrees, okay? But this also works on radians. So go ahead and pause the video, find out which one of these functions. Let me go ahead and hide my panel right here in my video so we have more space. Okay, so which one of these angles add up together? And just a friendly reminder, we have theta is equals 0, 30, 45, 60, 90, 120, so on and so forth. All the angles that we know of in the unit circle. Okay, so ideally, what we're going to go ahead and do is find two of these, add them together, subtract them, whatever the case may be, to get equal 75. So what cosine, what theta plus what beta gives me 75? Or what alpha minus the beta gives me 75? To keep it in simplest forms, a lot of the students went ahead and chose angles in quadrant 1, which is perfectly fine, 30 plus 45. Friendly reminder that the 45 could have gone in front because this is addition and the order doesn't matter. If it was subtraction, that does matter, right? Because 30 minus 45 is negative 15, and 45 minus 30 is 15. Okay, so we know that 30 plus 45 gives me 75. So therefore, I'm going to go ahead and look at my cosines. So I'm going to look at the cosines, which are these two formulas, and they're being added. So I'm going to go ahead and choose the one right here, this right here. This is going to go ahead and tell me what I need to do. So ideally, this is saying, hey, cosine alpha cosine beta minus sine alpha sine beta. Sorry about that. And I know there's a YouTube video that shows us how to memorize this. Luckily for us, we will be given this formula sheets on the midterm exam. So you don't have to stress about memorizing them if you don't need to. Okay, so let's go ahead and substitute everything in. Let me switch colors real quick. And I don't know what's going on here. Reinstall my tablet. Okay, so keep in mind this is alpha, this is beta. Since it's addition, they could be swapped as long as you make that change in the substitution. So we have cosine of alpha, which is 30 degrees, times cosine of beta, which is 45, minus sine of alpha, which we just said was 30. Whoops, 30. I put two parentheses in there. Times sine of beta, which we know is 45. Okay. Now here comes the part where we actually go ahead and solve for this. Cosine of 30 degrees. Well, keep in mind, if you've been studying your flashcards, it should be like easy evaluations. If not, we can go ahead and do the little unit circles, right? The little triangles. So cosine of 30, we have our little 30 in quadrant 1. This is 1, this is square root of 3 and 2. So cosine of 30 will give me square root of 3 over 2. Cosine of 45, I know this one. This is square root of 2 over 2. We did it just now in Duna. Minus sine of 30. Well, we can use that same triangle and we can see that the opposite side is a 1. And my hypotenuse is a 2. Sine of 45, keep in mind, sine of 45 is also square root of 2 over 2. If you're struggling on how I evaluated these guys, you could draw your little triangles, or you can go and study with your flashcards some more, or I actually made a lesson on how to evaluate trig values. Okay, so last but not least, we're going to go ahead and um, simplify. So this right here is being multiplied. So we know when we're working with fractions, we multiply straight across. So square root of 3 times square root of 2 is square root of 6. 2 times 2 is 4. Minus, we do the same thing. 1 times square root of 2 is square root of 2. And 2 times 2 is 4. Okay, so from here, a lot of students like to go ahead and subtract the insides and say square root of 4, but actually keep in mind those are not like terms, so it has to stay square root of 6 minus square root of 2, and then the 4 stays as the base. Okay. All right, let's go ahead and try the next one. Sine of 105. Now, we're gonna go ahead and find two numbers that either add or subtract. But keep in mind, this is sine. So we're going to use one of these right here, right? This right here was sine. So therefore, we're going to use one of these. Okay, so go ahead and pause the video and find me two numbers that either add or subtract to this value right here. Okay, so we have sine of 105. We can go ahead and do a couple of things. We can go ahead and say that 60 plus 45 is 1. And I believe we can also do 135 minus 30. Yeah. So it's pretty much up to you. 135 minus 30. And that's going to go ahead and decide which one you use. So if you want to go use the first one, it would be this one right here. If you want to use the second one, that's subtraction, you would use this one right here. The only thing that changes, guys, is the sign right here, the plus and the minus for sign. Okay. So my students like to do the ones in quadrant 1 because for them it is easier to do those. So we're going to go ahead and see that the fraction, so the formula we would use would be the one on top. That says sine of alpha plus beta. So we have this right here will be our alpha, this will be our beta. Unfortunately, we won't use this 135, but I promise you it does work. Just that 135 will be in quadrant 2. So okay, so from here, we have that sine of 60 plus 45, and we're going to go ahead and substitute everything. So we have sine of alpha cosine of beta plus cosine of alpha sine of beta. And we're going to go ahead and substitute everything. So we have sine of 60 times cosine of 45 plus my cosine of beta, which we said was 45. What am I? Sorry, of alpha. Whoa, of alpha, which is 60 times sine of 45. There you go. That should be good. Okay, so from here, what we're gonna go ahead and do is simplify everything. So let me go ahead and get some red. So sine of 60, guys. So I'm gonna go ahead and do that little triangle already. 60. The opposite side is square root of 3. My adjacent is 1 and my hypotenuse is 2. So sine of 60 is opposite over hypotenuse. So that's square root of 3 divided by 2. Cosine of 45. That one is going to be my square root of 2 over 2. Plus cosine of 60, that's my adjacent side, which is 1. So 1 over the hypotenuse, which is 2. Sine of 45 is going to be my square root of 2 over 2. That is the same for both sine and cosine. Okay, so from here, we're going to go ahead and simplify. Square root of 3 times square root of 2, that's square root of 6. You just multiply the insides. And 2 times 2 is 4. Plus, we're going to go ahead and multiply these fractions straight across. So square root of 2 over 4. This gives me, keep in mind, this square root of 6 is not the same as square root of 2. So you can't combine them just like that. So this is 4. So square root of 6 plus square root of 2 divided by 4. Okay. Let's go ahead and try one more, but let's think about it backwards. So we have sine of 42 cosine of 12 minus cosine 42 sine of 12. So this looks a little bit overwhelming, but ideally I have seen this somewhere before. So hopefully you're able to recognize that, hey, aren't these the ones from the right hand side? Aren't these the ones that they are equal to? Well, they actually are. So we're going to go ahead and see that, hey, this sine, cosine, cosine, sine matches these ones right here. Sine, cosine, sine, cosine. It has a minus, so it has a minus cosine sign. So actually I'm using this one right here. Does that make sense? We have this alpha, this beta, and we know the subtraction. So that's how we're able to see that, hey, they actually gave me this right here. And I'm gonna go ahead and compress it back into just being a sine alpha minus beta. So we have that sine alpha, which is 42, minus my beta, which is 12. We simplify this, it gives a sine of 30 degrees. And I'm pretty sure we can go ahead and solve for sine of 30 degrees, even if that means we have to do our little triangle, 30 degrees. Opposite is 1, hypotenuse is 2. So this would be 1/2 as my solution. Okay, so hopefully this wasn't that bad. So ideally this would work the same for our tangents, whether it's subtraction or addition. Okay. So for Paradox, I went ahead and gave us 3 very, very similar examples. Okay, so sine of 105, sine of this 20, cosine 10, plus cosine 20, sine 10. So go ahead and give these a try. And the last one was cosine of negative 115. Okay, so hopefully these aren't that bad. Please do reach out to me if you do have questions. And I hope to see you guys after the Thanksgiving break. All right, guys, laters. Bye-bye.